Okay, good morning, everybody. Thank you for joining today for our water quality topic for the Oceania Geospatial Symposium, or our community of practice of water resources management. This week, we're going to be having another new topic. I'm just going to go through. I just wanted to reintroduce Pearl Winchester as the lead co-animator for this water resources working group. So Pearl, I'll pass to you to introduce yourself.
Good morning, everyone. So my name is Pearl Winchester. I'm originally from New Caledonia, but right now I am in France for my studies. I have been working 14 years in the water department of the government of New Caledonia, and now I'm working for Insight in New Caledonia, which is a member of the ART GeoDevNC. It's a network of technicians in GIS. And you can find my LinkedIn profile here. I can send the link to you if you need it. Thank you for joining us today.
Thank you, Pearl. Yeah, and I'm Nick, also supporting this community practice for water resource management and hydrology. Currently working with SPC, but also completing my thesis on surface water and riparian vegetation environmental monitoring. And we do invite you all to also introduce yourselves in the chat, just your name, your current role or function, and the country you're based in. So we invite you to just add that into the chat, and I think maybe yeah, we could have some examples from Pearl or Ashnil. So for today, we're inviting Mr. Ashnil Sharan, who is with CNR Consulting, based in Australia. He's a hydrogeologist by background, so very interested in groundwater, and currently he's completing his PhD dissertation at James Cook University in Townsville. He has a range of specializations, both in terms of geochemical and geophysical in relation to saltwater intrusion in coastal aquifers, and water monitoring, as well as looking at the transport of contaminants and more general kind of hydrogeology. We also had, unfortunately, one of our speakers could not join us today, Mr. Erisami from the government of Vanuatu, but hopefully he'll be able to join us in a future webinar. So just a little bit of background about this group. So this working group. It's been set up through the collaboration with community of Oceania Geospatial to support sharing of information and best practices amongst different groups within the region, particularly within this intersection between people who are practitioners or interested in water resources, people who also make use of geospatial tools and capabilities, and people who are based in the region. So basically the confluence of these three areas are what form this working group. And we've covered a range of topics already, including natural disasters and tropical cyclones, droughts, rainfall, flash floods, and looking at also at climate change, participatory monitoring, and a range of different areas. So I will now pass to Pearl, who will give some more background on some of the topics that we are covering.
Yeah, I just wanted to share with you this slide that I actually got from the SPREP in Samoa, which is who took the information from the United Nations. And so it's just to show, it's a summary of the climate change impact on the water security that we must anticipate in our countries in the coming years. And I'm not going to read everything, but what is most important is that pretty much all of them will have impacts on water pollutions, or water quality. This is something that I wanted to highlight today actually for you. And so, as we have been seeing in our previous webinars, the scientists are telling us that we will face more frequent or intense floods. This is very likely. We will face higher water temperatures with high confidence, and the most important is the increased rainfall variability that is very likely, which will means more drought and more rain in a short period of time. So this is really something that we should work on all together. Next, please, Nick. Today we are focusing on water quality measurements in rivers and underground. And so I just wanted to have a quick reminder of how water quality sampling works, actually, if some of you have never seen it. So you actually take the little sample of water directly from the river here on the drawing. This specimen is split in as many child specimens you need to get the preparation and analysis that are done into laboratories most of the time. You can complete the sampling in the river with some in situ measurements with some special probes. Next. And if you are looking for underground water quality sampling, it's exactly the same process as before. After you actually got the sample. But I just wanted to show you that getting the sample from underground water quality needs more devices. So you need pumping device and water levee gaugers while you're actually taking the sample to make sure that you're pumping at the right level of water. And after, it's exactly the same process. Once you get the little sample collection jar here filled up, you're ready to get your sample into the laboratory. And Ashneil, which is our expert tonight, will tell us more about that for sure.
So, Pearl, I wonder maybe we could have Ashneil, if you wanted to just introduce yourself a bit more. We kind of already introduced you a bit earlier, but if there's anything you wanted to add, and then we might pass, I believe, to we might have an interactive poll.
No, it's after. No, it's time for Ashneil for his presentation.
Okay, we'll start with the presentation first. So I will pass to Ashneil first, and I'll let you share your screen, Ashneil.
Yeah, thank you very much, Nicholas and Pearl, for giving me the opportunity to present here. So I'll be talking about saltwater intrusion and groundwater modeling. So I'll be presenting a case study that I'm working on. So let me share my screen first. So are you able to see?
Yes.
Yep.
Can see.
Sounds good. Right.
Great.
So yes,
you.
The topic for today's presentation is I'll be talking about the management of saltwater intrusion into using 3D modeling softwares. So this 3D model is the first for Vanuatu, which I developed with the help of I think Ari gave me some data, so which helped me to develop a 3D model for the aquifer. Yep. So as saying along, so as Nicholas introduced me, I'm Ashneil and I'm a hydrogeologist. So I'm affiliated with James Cook University and also at CNR Consulting. So the content for today's presentation is that I'll be talking about a brief background of groundwater and how the models is constructed. Then I will talk about the materials and the method, like what method I've used to develop the models. Then I will also discuss about some results and how it was analyzed. Then I'll talk about the conclusion and the significance of that model, why groundwater modeling is conducted, and then there will be some question and answers at the end. So as you know, like when there is a lot of population growth and all, so what happens, there is over abstraction of groundwater from the aquifer to meet the demands of increasing population. So what happens, that over abstraction leads to one of the environmental problem known as saltwater intrusion. So saltwater intrusion is the movement of saline water into freshwater aquifers. So the more water you pull from your freshwater aquifers, the more saline water goes into your freshwater aquifers. So a simple diagram here shows how saltwater intrusion occurs. So saltwater intrusion occurs through two means, from human activities, which is the anthropogenic activities, and also from natural activities. So this diagram shows here, if we keep on pumping fresh water from the freshwater aquifers, so what happens, this interface, so this is the interface which separates the salt water from fresh water. So if we keep on abstracting the fresh water, this interface moves more towards the landward side, taking the salty water inland, which eventually causes saltwater intrusion. And also, if there is a sea level rise, so if there is a sea level rise, what happens, there is vertical inundation of salt water. So it comes on top of the land, and then it particularly infiltrates into the groundwater system. And there's also different kind of pollutions that contaminate groundwater. So if there's excess CO2 emission in the atmosphere, what happens, the excess CO2 gets absorbed in the groundwater system. And also, when you abstract a lot of groundwater, there are trapped CO2 into the groundwater system, and it gets released in the into the atmosphere. So today I will discuss about the saltwater intrusion mostly. So to show how saltwater intrusion occurs and all, so I chose a small Pacific Island country, which is Vanuatu. And also in Vanuatu, I have worked on Efate. So Efate is where the capital city is, I think, Port Vila, and they use mostly groundwater. So what I did, I developed a groundwater model for this catchment, as you can see from here. And these are the bores here, which they use. There are, I think, 7 or 8 bores, which is clustered near the international airport. Yep, so this was the study area. So to develop the groundwater model, we needed a lot of data from the field, which was the pumping data, and also a lot of hydrogeology data, recharge and all. So by using all those initial data, I developed the flow model, and after the flow model, I developed the transport model. So flow model was developed in ModFlow, and then the transport model was developed in MT3DMS. So a simple diagram here shows how the model was developed. So this is a transient input. So the transient input was the pumping rates, the recharge, the evapotranspiration, and all this data that is needed to develop your flow model. So using the data, it was fed, and our flow model was developed using ModFlow. So once your flow model was developed, then what happens, we took all the outputs from the flow model, and then we simulated our transport model. So the transport in this case was salt. So we wanted to see how the salt was encroaching into the groundwater system using the current pumping regimes in Efate. So we have used MD3DMS. So, and we have also used COG. So COG is the combination of the flow model and transfer model. So COG solves them simultaneously. So once this was done, the numerical simulation model was ready, and then we got our outputs. So we simulated our model for next 20 years to test different scenarios. Like we did a lot of sensitivity analysis, we did a lot of uncertainty testing. So some of the results that we got from our 3D model is shown here. So before getting any results, what we did, we calibrated and validated our model. So we need to calibrate and validate our model, otherwise you will not know if your model is correct or not. So how we calibrate and validate our model is by using field data. So once you have developed your model and you want to see if it is correct or not, so that means you need to calibrate your model. So we have used the hydraulic head values, we have used the soil concentrations to calibrate our model. So once the model was calibrated, we have simulated different scenarios of how the saltwater intrusion will occur. So as you can see from this diagram here, so in part A, this is the simulation after 5 years. So after 5 years with the current pumping regime, what happens? The saltwater intrusion has moved at this stage here, as you can see. So after 10 years of pumping, the saltwater intrusion has moved up till here, and after 20 years, the saltwater intrusion has contaminated the bores, as you can see. So after 20 years, with the current pumping regime, FATA will not be able to use these bores because these bores will be contaminated with saline water. Then there are some other results. So once we found the problem that was saltwater intrusion occurring, so what we did, we need to find some solutions. So using the calibrated model, what we did, we simulated different scenarios of how to manage the saltwater intrusion. So the first scenario that we simulated was using the barrier wells. So barrier wells is like a place near the coast, so that abstracts saline water, and then it reverses the hydraulic gradient, and it doesn't allow the salt water to infiltrate into the freshwater aquifers. So that's the job of the barrier wells. And also we have added injection wells, and we have also added injection well and barrier wells. So injection well is where you vertically recharge, or so you put the fresh water back into the aquifer. So that is the job of the injection wells or the recharge wells. So as you can see from here, this is the base case. So this is the base case, and this is C, which is the addition of the barrier wells. So the barrier wells were placed near the coast. The barrier wells were placed near here, and it was simulated for 20 years. So this is first year. This is after 5 years, after 10 years, 15 years, and 20 years. So when you compare with the base case, the barrier wells reduces the saltwater intrusion going into the freshwater aquifers, as you can see from here. So here there is no management strategy. It's just plain pumping going on from these bores. But here, what we did, we added barrier wells, so it reduced the saltwater intrusion. And then in part D, as you can see, this is the addition of injection wells plus barrier wells. So what we did, we removed the water from the barrier wells, we have treated it, and then we have placed back into the aquifer using the injection wells. So that is injection well and barrier wells. So as you can see here, the saltwater intrusion has significantly reduced. So let's compare after 20 years. So the intrusion rate has decreased when you compare with the only barrier wells, and we also compare without any management strategy. So that was some of the management strategies that we simulated. So there's some other results, as you can see clearly from here. So this is the base case, and this is for the barrier wells, how the saltwater intrusion tau has been reduced, as you can see. So this was the base case. The saltwater has come near this, so it has come near the production bores here. So your production bores are placed here. So using the barrier wells, it has reduced, and using barrier wells and injection wells, it has reduced further. As you can see, the distance from the barrier wells to the saltwater intrusion tau is reduced. And the last case I did was the sea level rise. So what happens? We simulated if there will be a sea level rise, what will happen to the saltwater intrusion rates. So as you can see, sea level rise increases the saltwater intrusion right here, as you can see in the last tab here. So in general, what 3D model does, it simulates the saltwater intrusion rates in Tangame coastal aquifer. And what we found out is that the hydraulic barriers, which are the barrier wells, the injection wells, it reduces the saltwater intrusion in Tangame coastal aquifer. And also what we found out is that the sea level rise affects the saltwater intrusion rate, as you have seen in the previous slide, how the sea level rise affects the saltwater intrusion. So as the sea level rises, the saltwater intrusion also increases. So we have shown that using the 3D model. So the significance of this research is that this is the first ever 3D model developed for Vanuatu, and there are not many 3D models developed for Pacific Island countries. So Vanuatu is the first one, like we have developed the first 3D model for Vanuatu. And using this 3D model, as I have mentioned earlier, uncertainties could be tested. So uncertainties, for example, like if you have your calibrated model, so using that calibrated model, you can test different scenarios and uncertainties. For example, there will be a long drought in future. So you can simulate that using a 3D model by increasing and decreasing the recharge values. But first you have to have your 3D model calibrated and validated. Then you can say, okay, this represents the real aquifer or the real catchment area, and you can use the 3D model to test different scenarios and do uncertainty testing. And also you can do sensitivity analysis. So sensitivity analysis, for example, you are doing some mining. So when you are mining, you are going to blast the ground. So when you are blasting the ground, what happens? You are changing the hydraulic conductivity of the soil and also the porosities. So that is sensitivity analysis. So you can test that using a 3D model by changing your hydraulic conductivity and see how the groundwater flows and how the transport of the contaminant flows when you change the hydraulic conductivities and all. So using the 3D model and the results from here, you can develop policies and regulations that manages the saltwater intrusion in this case, but it could also, the 3D model could be also used to manage other contaminants. For example, you are dumping rubbish or something, so there's a leachate leaking. So using a 3D model, you can simulate different scenarios and you can see where the leachate has gone up to. So using that results from 3D model, you can develop different policies and all. So not only leachate, there's also if there's oil spill and all, so it can be simulated using a 3D model. So some of the best practices that we can all practice is that we can conserve and save water now, because we need to save water for future generations as well. So also do not contaminate groundwater, because groundwater has been there for millions of ages and is going to continue as such. So if we contaminate groundwater or by different techniques, for example, dumping rubbish and all, and mining, all these things contaminate groundwater. So do not contaminate groundwater. Also dispose of solid and liquid waste responsibly. So if you are just dumping some waste nearby, that what will happen, it will infiltrate into the groundwater system, and then it will be passed into your production wells, and you're going to consume that and get sick and all. So you need to dispose your solid and liquid waste responsibly. Some of the tips from this is that you need to start monitoring groundwater and surface water. What I have seen in the Pacific Island countries, there's very limited monitoring of groundwater and surface water. So when we want to develop models and simulate different scenarios and all, there's no data available. So we have to write to a lot of people, and still there's no data. It's very hard to get data from Pacific Island countries because there is no monitoring going on. And there should be up-to-date database for public access. So for example, in Australia, there is a big database which is accessible to public. You can go to you can get all the data for groundwater, all the bore data, the bore laws, and everything is publicly available. It should be same or the similar for Pacific Island countries, because Pacific Island countries are most affected due to climate change and all these things. And groundwater is mostly used in a lot of small countries. So we need our database and also get a groundwater model done. If you have a lot of data and you are using a lot of groundwater, you need a groundwater model to be done, because you need to know what scenarios and you can test different uncertainties and all. So you need a groundwater model to test different scenarios. So in saying that, thank you very much for your time. So if you have any questions, we can go ahead with that. Yeah, over to you, Paul.
Yeah, thank you, Ashnil. And yes, as you said, if anybody has some questions, we can go ahead with the question for Ashnil. I'm gonna give you the font. Sorry. Up, paramètres. How does it work?
Just while you're working out the forms, Pearl, I had a question. Thank you, Ashna, for the presentation and the sharing the outputs of your hydrogeology model. Yeah, really interesting work, particularly looking at the future scenarios for saltwater intrusion. I think one of the questions I had was, to what extent did you have to use geology data as inputs into your model? What does the how varied are the dominant lithologies or the different geologies across that Ifate catchment? And to what extent does that impact on the upconing of saltwater intrusion and the hydraulic connectivity of saltwater intrusion across the model outputs?
Yes, thank you. So the data that we have used is that we have used the bore log data. So using the bore log data, we have found out at what depth what soil types are. So based on that, and also there's some I think there are some previous studies which have been conducted in Ifate, which shows the different hydraulic conductivities of different catchment areas. So we have used that data as well. And yes, so getting data is very difficult. from Pacific country, unless you know someone or people have been monitoring. But up to my understanding, I'm not sure if people are monitoring groundwater and surface water. I'm not too sure about that, if they're monitoring or not. But yeah, so using those data, we have developed the model, and also recharge value is very important. So I think the recharge of the climate data is available online, so we can get that from there. Yeah, and evapotranspiration rates is also online. So yeah, all this data was used to generate the model. And the depth we have gone down, like so it was based on the bone works. So I think we went down to 80 meters below the ground, because most of the aquifers in Pacific countries is shallow, so it's up there because of heavy rainfall and all. So we don't need to go a bit down and all. Like for example, in Australia, what we are doing, we are going like around 600 meters below, because there are different kind of aquifers, and it's inland, where there's like around 300 millimeters of rainfall per year. But in Pacific countries, it's more than 1,000 millimeters per year. So, yep.
Yeah, I see that Chris has a question. Chris, I think you can open your microphone and get your question.
Hi, can you hear me?
Yes, we can.
Okay, cool. Yes, thank you, Ashni, for your presentation. Very interesting. I just wanted to ask about the barrier wells that you developed. What is the quantity of barriers that you have placed, and how did you choose the position? Was it just along the coast, or because I guess you would have to choose pick those spots based on your geological setting, and the threshold of the barrier mitigation. How many are there, or how did you choose the number, or will you estimate in future? Because I think maybe the number of wells would depend on the extraction that is taking place. Yeah. So
Yep.
yeah. Just I just want to know how
Yep.
you pick those
Yeah.
spots, or
Yeah.
the number.
Yeah, that's a good question. So the thing is, like with barrier wells, so before choosing the barrier wells, what we did, we have developed the model, and then we have calibrated and validated the model. So once you have calibrated and validated the model, then you can say, okay, this represents the real Tangambe coastal aquifer. So using that, we can simulate different scenarios. So in our case, we have simulated this scenario. So it's a scenario. So we have placed the barrier wells. So barrier wells are mostly placed near the coast, and also, yeah, of course, using the geology and all. So we have placed near the coast where the saltwater intrusion was like intruding more. So as you can see from here, so as you can see from here, the saltwater intrusion was intruding more from here, this place. So can you all see? Yeah. So we have placed it here. So once we have placed it here, as you can see, the saltwater intrusion didn't reach the freshwater aquifers. So this is how we did, but there's another way of placing barrier wells. So that is an optimization problem. Sorry about the noise. So that's another optimization problem. So we need to optimize the results from the simulation model, and then based on that, you're going to place barrier wells. So that's another problem that we have done as well. So that is simulation optimization problem. So that will tell you where to place your barrier wells and all. But for this case, so this was just a scenario based. So once we have calibrated our model, we have just placed it near here. to stop the saltwater intrusion going in. And as you can see from here, the saltwater intrusion didn't go in. And also using barrier wells, it's expensive as well, because you're going to drill and all, and then what are you going to with the abstracted water, because that's salty water. So the less number of barrier wells, the better. So that's why we have just placed near here. Otherwise, we could have placed all around. So that's not feasible. Yeah. Hope that answers your question.
It'd be pretty interesting if you had a test, physical, because I don't think your model considers the geological layers in your mod flow.
It considers different layers and to different depth.
Because if you put barrier layers wherever you put it, of course, it will show some improvement in the results. But yeah, I would think that play around a little bit more with it.
Yeah, so that's what I said. Once you have your calibrated model, you can do anything with it, because that represents the actual geology and everything, which you cannot do on the ground because it will cost money and all, it will take time. So that's why we develop models, so that that model could be used to simulate different scenarios and do uncertainties and all. So this is one of the scenarios that could be tested with barrier wells, injection wells, and all these things.
Okay, just a final question. Yeah. What was the in the study area? What was the water resources management practice before your study? What made you decide to, or something's happening there, or what did they used to do before this?
So what happens? We got the water quality data. So based on that, the electrical conductivity of the water was high, so which shows there's saline in it, salty. So what we did, using the data, we developed the model, and we've also calibrated it using the salt concentration of the water. So based on that data, okay, this is what's happening. We need to develop the model now to find out different techniques of managing it. Otherwise, it will be too late. Just like, for example, in Kiribati, what happened? It's most of the water is contaminated. Yeah. So we want to stop it now. So the data was given by government of Vanuatu.
Thanks.
Yeah.
Much appreciated.
Thanks, Ashnil. You have a question from Anesh, actually, who is asking what was the initial salinity results prior to the barrier wells? Like, can you see the difference? I mean,
so
can you see
salinity results prior to barrier wells? So prior to using barrier wells is shown here very clearly. So here there was no barrier wells used. So the salinity was around 40 kg meter cubes, or around 40,000 mg per liter. That was a salt concentration. But using barrier wells, it reduced significantly by 4,000 mg per liter or something like that. As you can see from here, reduced, and it further reduced when we use barrier wells and injection wells together. Yep.
Thank you. I have a question, actually. How much time did it take for you to create the model and to get all the scenarios?
So to develop a model with, for example, a real site and using real data, it takes more than a month to get the data and sort the data, provided if you have all the data. Otherwise, you have to hunt data, so it will take more than a month. Once you have the data, then you need to set the data in different formats, which ModFlow and GMS uses. So we use GMS, which is groundwater modeling system. And to develop this model, it takes nearly 2 to 3 weeks, but it takes a lot of time in calibrating. because you need to calibrate your model properly. Otherwise, you will be testing different scenarios and saying, okay, this thing is without any solid evidence. So once you have calibrated your model, then, for example, you have a monitoring point A, then when you have simulated and said, okay, this is the head value at monitoring point A, for example, it's 20, and from the field data, you can compare the results. So if the field is 19.5 or 20.1 or something like that, then you can say, okay, this is a well-calibrated model and gives similar results as the field. Then you can use that to do different scenarios and all. So yeah, it takes around 3 to 4 months tops if you have no data from the scratch. But if you have data, 2 to 3 months should be good.
Merci. Yeah, Anesh, go ahead.
Hi, Ashnil. This is Anesh from Fiji.
Yeah.
I agree with you that continuous monitoring it's very important. However, because IFATE has contamination issues from various sources, runoff and other things, like how does this abstraction from these barrier wells will impact contamination from other sources? I think it will be really important if that is included into the modeling, to include these contaminated sources and to see the impact of the movement of the contamination plumes across, or how it moves. Thank you.
Yeah, that's a good question too. So that's contaminant transport. So what? So at this point, I just got the data for electrical conductivity and all. So we did saltwater intrusion. But if we have data for other contaminants, for example, oil or leachate leaking from the landfill and all, so we can develop a contaminant model as well, and we can show how the plume is moving, and using that and using the calibrated model, we can simulate different scenarios of how to manage that plume. And also that plume will be, for example, dependent on all the other factors, for example, the absorption rate of the soil, the chemical reactions, the advection rate, and so all that thing is dependent on the flow of the groundwater. So that has to be done first. So we have done that model already, which is how the groundwater flows. So once we have the once we have information about the other contaminants, we can do that as well. But we need data to do that. And especially in countries, it's very difficult to get the data. Yeah. Hope I've answered your question, Anesh.
Yeah, thank you.
I think I have one last question for you, actually, Ashnil. Where's the water coming from? The water you put back into the injection wells here? Where's the water coming from in the first place?
So as you can see in D here, so what we did, we have abstracted the water first, so using barrier wells. So we have removed the saline water and we have treated it, and then we have put it back into. So, and of course we can get the water from rivers and all, because it rains a lot in Efate and in Pacific countries. So you must be knowing, yeah, how it rains and all. Yeah. So
yeah, but I guess that economically you need to anticipate the need of energy to get the water back.
Yeah, not only water, we can also, like, for example, push the saltwater intrusion away from the freshwater aquifers using air. So what we do is, now people are pumping air into the aquifer, and what it happens, it pushes the interface towards the seaside. So that's another technique of doing it. And also you can remove air from the soil particles. So when you remove air from the soil particles, it's going to stick together. So in that you are changing the hydraulic conductivity and the porosity of the soil as well. So that's different technique as well. So there are different techniques you can manage saltwater intrusion now. So that technique could also be used to manage other contaminants, not only saltwater, so leachate, oil, and all.
All right. Well, thank you. I don't think we have any more questions. Maybe somebody has one last. If not, I will pass the floor back to Nicholas.
Yep,
And we will thank you a lot, Ashneil.
no problem.
Thank you very much, Ashnil, for the great presentation, and thank you everyone for joining and all of the questions that came through. We had a lot of questions coming through, so that's always a good indicator of a presentation that has engaged with the audience. If there are no further questions, Pearl, I wasn't sure if you wanted, if there was any poll we needed to include, or if not, what else we would have.
No, yeah, the poll is ready. I was about to launch it, but you need to share your screen with the PowerPoint.
Sure. No worries. Okay, I
Where
will do
is
that.
it?
Just give me a second. Okay, here we go. Poll time. So this is part of as part of the working group. We have these webinars. We have invite these speakers to come and share about their research and their work, but we also want to build this community of practice to kind of work towards some shared objectives and to work towards building something new. And so for the region, we asked some of these questions around, for example, this question here is around us trying to help prioritize and rank different water quality parameters and based on your experience, based on the work you're doing. So I think this first question is really about, what is the main water quality parameters that you work with and that you monitor in your country and the work you're doing. And so we have some examples here of some of the parameters, but I think Pearl will launch a poll for us to go through this.
I did. It should be working. Okay. Can you see the poll? Oh. It's working for me, but
it's working for me too.
Maybe I'm the only one.
I'm getting it. There should be just like a little window that pops up on your screen with a few different options you can choose from. But if that may not work for everyone, can you maybe just raise your hand if it's working?
All right, you can type whatever what you can do, Alex, and the other ones, if it's not working, is you can actually type the answer in the chat. And
it seems to be working for Jean and Eleanor. It seems to be working, but for some others it's not working, which is strange. So, okay, the bot is disabled for Alex. So I guess people can type, you can type your answer in the chat, like Pearl said.
Yes, please. Yeah, for Alex, what you can actually think is what should be a priority if you would be monitoring it in your country. What do you think would be the priority? You can actually say it this way, even if you're not the one doing it. And I see someone raise its hand. Who is it? Eleanor. Eleanor, you raise your hand.
I think Eleanor is raising her hand to say that it is working.
It is working. Alrighty.
Thanks, Eleanor. Okay, I'm gonna say to everybody.
Yeah, we do agree a lot on the coliforms, I guess. If I would be answering for you, can I answer for you? I think I can. Do we still have people waiting to answer? 2, 3, 4, 5, 6, 7. I have 6 answers and we are 11, so
And
8.
apologies to anyone having breakfast or morning tea while we talk about all these coliforms and
Yeah.
matter on the beaches. So
All right, so if I look at the answers, what I can see is that pH is the first one, and well, actually, coliforms is the first one because I can count Anesh and Alex, and pH is number 2, and then turbidity, temperature, and nitrates are pretty much equal. So great, thank you for your answers. I don't remember what was next. So please show us, Nick. Oh, yeah. As we have Erie that is not available, we thought about quick open discussions in your countries to see what difficulties you're facing in water quality parameters and analysis, if you want to talk about that, or if you want to talk about the water quality laws that you are using, if you have like special laws in your countries or not. And if you want to share your experience about the water quality databases you're actually using, who is the main question for this one is who is actually responsible for the water quality main database in your country? So it's open mic if you want to share.
Yeah. And I think some of these questions as well, we might have follow up through the email list as well. I think, Pro, is that right? We might, through the email list, there might be some follow up on these questions. Potentially into the future. Did we have a link to maybe to the LinkedIn group that we can share for some of the newcomers as well? I'm just trying to
sure.
grab that.
It's after. Yeah, it's coming after.
Oh yeah, right. Terrific.
But I can't set it here. Let me see. I'm gonna paste it now. So nobody wants to share its experience of water quality in his country?
Well, I have a question.
Go ahead.
So is there mining going on in different Pacific countries, and who monitors those stuffs? For example, groundwater, surface water, interaction with the pits, So who monitors that? Or is there anyone monitoring or not? So yep.
So for mining, you said that's what you said?
Yes.
Well, I can speak for New Caledonia. For New Caledonia, we have the water department and we have the mining department of the government of New Caledonia. And so the mining companies are supposed to give their data to the mining service of the government. And the trouble is, at the moment, this data, we have hydrogeology and hydrology data and water quality, actually. And this data is, at the moment, centralized at the mining department, but it's not shared towards the water department. So this is just an example of difficulties of data sharing that we are facing in New Caledonia.
So what do they do with the data? They just keep it hidden or something?
Yeah, it's in the reports. Yeah, it's in the reports, and so they just check that the reports are, how to say, valid in front of the law or the standards that the miners are not supposed to overcome. And that's the only use that it's done. It's just one control. It's not for big statistics.
Okay. Yep. Thank you.
Not yet anyway. I hope it's going to get there someday, but it's difficult.
What about in other countries? Like if there's someone from other countries?
I might invite some of our guests to speak. So we've done a lot of work actually at SPC and with Alex, I believe, who's still on the call. Feel free to jump in at any point. but we've been working with SPC and Alex for at least for Fiji, and we did a bit of work in Tonga on working with the relevant local authorities, such as the Mineral Resources Department, similar to the equivalent in New Caledonia that Pearl just mentioned. Usually it's the Ministry of Lands, and then they would have a minerals or geology section that we've worked with in these countries. And we've been working on using satellite imagery and machine learning models to detect mineral resource extraction. And so there's a range of challenges associated with this, including cloud cover, including confusion with the detection of other naturally occurring bare lands and gravel bars and things like that. This again is there's more of a focus on surface landscapes and surface water. We can't use the satellites to look at the regolith and the groundwater or anything, subsurface. But there's also water observations from space, which could maybe shed light on changes in the groundwater table, but that's at a very coarse resolution. Alex, feel free if you want to add anything to that, but Alex has been key in helping to develop some of this work with SPC on monitoring mining activities. Yeah, I think I've talked too much and covered it all already. But yeah, does that answer your question a bit more, Ashnil?
Yeah, sounds good. Yep. Thank you.
Yes, Chris, go ahead.
Chris, please, yeah.
Sorry, since you're here, Pearl and Nicholas, I just wanted to put forward something of I'm part of the International Hydrology Association for Hydrological Sciences, so IAHS committee member, and we're looking to put together so we have the Latin group and the African group already done. The African just was made last year. So I put a proposal forward to do the Pacific Islands, like a island group. Yeah, and I think I should probably hand it over to you guys, since you've already got a platform here. I'm wondering if we can further expand on it. The benefits of having this would be really great for us. We can have we don't have conferences like major water conferences in the South Pacific, so this gives us a chance to put ourselves out there, like in Fiji probably, or New Caledonia. And IAHS has about more than 10,000 members, and every 2 years there's a major conference. So I was meaning to do this last year, and quite busy and had no contacts in the region. So yes, I'll just put in the chat here the link, and maybe we can reach out to each other and probably try and get as much people from the Pacific, so that we can have this setup. Yeah, that's it from my side. Sorry, I'm throwing this into this conversation. So
don't apologize. It's a great idea, actually. That's the thing. It's really the focus that we want to have. Try to get all of us, all the islands together. We got through the GIS, but it's transversal, right? So definitely it's with water, it's with whatever we need to. So if you think that it's a good idea here to get closer to IAHS, I do think it's a great idea. Sure, Nicolas, go ahead.
Oh, I think, Chris, you wanted to add a bit more first?
Yeah, no, if you attend the conferences, or if you just look at the committee members for major global conferences, I think we are underrepresented or not represented. Yeah, so I was thinking, hey man, we better do something to put ourselves on the world stage. Every time we keep, I think we keep, it's an opinion. So the climate change guys might go against this, but I think we keep advocating too much without doing the actual scientific work. You know, our volume is too low. Our output is too low. We are always going out and advocating, but
actually, I'm gonna talk before Nicolas. Nicolas, if you can just put back the PowerPoint from the webinar with the questions, please. Yeah, this one. You see at the bottom, there's one. No, that's the one. Yes, I actually added the gemstat.org your link, and it's just to show that there's actually almost no Pacific Islands data in this international database. So it's the same as you're saying. We are not represented in these international places because we don't have the data ourselves. The local data is not available, and so we can't push it back up to international levels. And I know that it's actually Jean Massenet that is with us here to try to get something more into a regional, what's the name? Well, conference and also regional organization. So it's on track, and our webinars is just the first step towards getting all of us together for water, for GIS, for environment, for climate change.
Awesome.
Sorry, Nicolas, go ahead.
No, that's okay. I wasn't sure. Anesh, did you want to go first? I'm just collating some hyperlinks here.
Hi, Nico. I think the data issue in Pacific is mainly because of ownership. For example, this is it's not actually an issue, you know. It's a deep lying problem, you know, and it's catching up. For example, like Fiji didn't have a water policy for many years now, and they just came up with it. I think last year or this year, which is a very good news. So the ownership was missing. So people don't know, or the organization don't know whose responsibility it is, or either that or they are stepping on other shoes. Like, you know, we have organization like Water Authority, Public Health, and Mineral Resources Department. So now I think the policy will help that, while in other Pacific countries, mainly the atoll countries, it's the ownership which needs to be instilled, you know, and it needs to be a holistic approach. Many times we just saw groundwater separate, surface water separate. I think it's time that, you know, I think it's coming now. You know, the Pacific are doing that. They're looking at it as a, you know, as a holistic approach where agriculture is coming together to work with water departments to improve the quality and moving forward, especially in these climate change scenarios. Thank you.
I'll pass to Ashnil just in a sec. I just wanted to share some links in the chat briefly first. So I've shared a few links to a few different conferences, upcoming conferences and events that will be happening in Suva and abroad in the coming months. There's the STAR conference, which is more of a geoscience focus. So that will cover hydrogeology as well as probably some hydrology. And also GIS and remote sensing. We have the we have the Oceania Geospatial Symposium, which I believe maybe Pearl or Jean can elaborate on when the plans for that coming up. And then we have the Pacific GIS Remote Sensing Conference, which will be held at University of the South Pacific. So these are just some examples of events that would be relevant for some of the people in the Teams room to join and meet in person, and maybe discuss next steps as well. I did want to ask, Chris, where are you based? Just briefly.
USGS, United States Geological Survey.
Also, you're based in the States?
Yeah, in Minnesota for a while, and in Japan.
Okay, fair enough. All right, so I will pass to Ashnil, and then Jean may have some to add as well.
Yeah, thank you, Nick. I just wanted to ask about Fiji. Like, do we have thorough monitoring program to monitor groundwater and surface water in Fiji, and also test water quality data from underground and also surface? For example, like in farming sectors where people use a lot of wells. So what they do is like they put fertilizers in their sugarcane farms, and when it rains, the chemicals from the fertilizer, you can say nitrate and all, infiltration to the groundwater system. So we want to know if there is some studies done on that, or if there are people monitoring data in those remote places and all. I'm not
Okay.
sure if this is the right forum to ask the questions or not.
No worries. I can start answering the question, but I might even pass to Anesh, who's worked in this space for many years. But my understanding is that we have the Mineral Resources Department's hydrogeology section. We also have SPC, who have a hydrogeology team. And both of those teams do a lot of work on monitoring, on one, pumping tests and monitoring of water levels, and mainly salinity and some of the other parameters, as well as kind of more focused on the water security side. So electrical resistivity tests to assess where drilling should occur for drilling new wells and bores. So that's work and I think that work is going to be scaled up a lot this year. There's supposed to be a lot of new bores being dug this year in Fiji. In terms of monitoring parameters like nitrates and phosphates and other water quality parameters, I'm not too sure to what extent that's being done. That might be a gap, but Anesh will probably know more about that because he's worked in this space for many years. So Anesh, I don't know if you can add to that.
Yeah, I think Nico, you are correct. It's gaining speed now, and MRD and Fiji government has, resource has been issued in the Pacific and Fiji as well. There's so many things happening, and no, there wasn't any policy, so it wasn't regulated. So even the government doesn't know how many boreholes they are drilled every year. But now it will be regulated, but it will take a bit of time. Government does have a monitoring program, especially in Vanuatu, and SPC provided some support with that. But I think now they will have automated loggers, which will be very efficient for them, and they don't have to go off-site all the time to do that. But yeah, the resource has been a major issue until now, but I think it's improving now.
Thanks a lot, Anesh. Yeah, I mean, Anesh is the right person for this kind of question because he's worked in this space for many years. But just to really zoom in on your specific, the second part of your question, Ashnil, on like more like agricultural runoff or agricultural chemicals, I do, from my limited knowledge, that would be likely to be a gap. That like the core parameters that are being monitored are more likely to be water level, maybe hydraulic conductivity and salinity perhaps, or electrical conductivity. So I don't think that nitrates and phosphates would be monitored on a regular basis. Maybe that would be Ministry of Agriculture more so in the soils. Yep. And just to highlight, Jean has made a comment, and Jean, you're welcome to speak to this, but my understanding is that like while Pearl has been leading this group on, and we've been co-animating on hydrology and water resources, but there will be also another group, working group for work on land degradation neutrality or on land use land cover. I'm not sure if that was what you were leading towards, Jean, but maybe Jean, you can speak to that point.
Yeah, thanks a lot, Nico. So sorry about not being that clear. No, actually, we plan to organize previously the symposium, the second edition of the symposium in Tahiti by this year. It has been postponed to next year, and we will match with the UNCCD, GeoLDM Regional Dialogue Forum. So they are organizing their own event. We were organizing ours, and we do want to make sure that we coordinate the actions, we pool the resources and so on, and we, do not solicitate too more the ecosystem. We all have a lot of things to do, many hats and so on. So it's important for us to match those key initiatives for the region. So what has been decided together was to postpone the event by 2025 rather than this year. We are not even sure on when it will be, but it might be Q2 or maybe Q3 of the next year. We will keep you posted indeed. About the group, so we still have this central page of like a community of Oceania Geospatial through LinkedIn. And based on that, parallel to that, we have those working groups. What we would like to do is to set up new groups, but it needs to get like pilots and people to animate it. So we have the chance here to get both Pearl and Nico to animate this water resources stuff. What is important to me, myself, would be to have something dedicated to land cover and land occupation. So this is the next step for us. I know I did not answer to your email, Nico, but I will do so. So still on my mind and of my priorities. And other ones could be about the events. So you'll be talking about events. So it's something to share about all events, incoming events, open to the community, etc., within the region, or even events interested for the regional geospatial community, even if it's not necessarily happening within the region. And any other ideas, basically, we talked about education, about like any domain, including land degradation. But my understanding is like land degradation should go through land cover and land use. But we'll have time to discuss this with the world community at the next OGS, hopefully. Hope that is clear enough now.
It is for me anyway. I think it's almost time to wrap up. And if you can, please, Nicolas, share again the slides, because there was one last question we wanted to discuss with you. Yeah, that's the one. Yeah, that's the question we had. So we just wanted to see if you have some ideas for the next webinars next year, because this is our last webinar for 2024, because we know that November and December are pretty busy with school holidays or big projects going on. And so I just wanted to know if you guys had any special subjects that you would like to see treated for next year. And you can actually type, or you can open your mic. Just let me know. Nicolas is actually sharing the few ideas we had. If some of them are the one you really want to see, you can actually type it also, so we know what priority we go for next year. So thank you, Ashneil. Thank you, Anesh. Perfect. Does anybody have any other idea that is not written here? All right, so I'm typing at the same time in my phone to keep all this. So mine water. Techniques of water monitoring. All right, and if you know anybody that could actually speak, yeah, yes, thank you, Jean. Let's talk about all of them, of course. If you actually know any speaker or anybody that would be perfect to be a speaker on any of this subject, don't hesitate to send us an email with the contacts so we can actually get to these people, because this has been one of the tough thing to do, is to try to find some local speakers from the Pacific Islands to the Pacific Islands, so we actually talk about something we are living every day. So if you really see anybody that could speak, don't hesitate to share the contact and talk about us, see if they are interested in being a speaker. It would be great. I think there's one last slide, please, Nicolas. Yes, and the last slide is thank you all. Merci beaucoup. We will see you in 2025. Stay tuned on our LinkedIn water resource group for the schedule for next year. And yes, we will keep you up to date at that time for the OGS and all the others conferences and gathering that could actually get us together, not only during the webinars, but also in real. We never know. Up. I'm going to send you again the link for the OGS, no, for the Community of Oceania Geospatial Water Resource Workgroup. So this is the Workgroup. Up. All right. Nicolas, do you want to add something?
No, I just wanted to say thanks. It's been a big year for us in this group, and hopefully I'm hoping to see more of you next year. And I think there was really great discussion towards the end about some of what we really want to get towards is what are the next steps? Where do we want to take this group, and what do we want to do with this in terms of building maybe some useful information products or policy recommendations as a part of this working group. So, and hopefully there'll be more chances to network through some of the conferences and platforms that we've shared in the chat. So yeah, thanks again for joining.
Thanks. Ashneil, thank you so much for speaking with us today.
Thank you very much.
Thank you everyone, and we'll see you next year. We'll send you emails and stay tuned on LinkedIn. Merci beaucoup.